Today we are looking at polynomials, and we're going to start by looking at adding and subtracting polynomials. But I want to make sure that we're all on the same page, specifically vocabulary. Vocabulary is an important part of, most classes, whether it's a math class, science, English, literature. We have to be on the same page in terms of our terminology. So first is the idea of what is a polynomial. We're going to use this term a lot. Well, a polynomial can be a single term, which sounds weird because we know poly means many, but it's a single term or most often a sum of terms, where all the variables have whole number exponents and no variable appears in the denominator. So 3x squared minus 2x plus 1 is a polynomial because all of the variables are whole number exponents, versus 2x to the 1/2 plus 4 is not a polynomial because 1/2 is not a whole number exponent. So that's just something to note a little bit about polynomials. In addition, we write polynomials in what's called descending order, descending powers. So it's looking at the largest, the highest power, the highest exponent, and writing that from the highest exponent to the lowest exponent. So go ahead and use your chat feature. See if you can't rewrite this expression here in descending order, looking at what is that highest exponential power. Use that term first and continue on to our next highest power, our third highest power, and our lowest power. Again, go ahead and think about it. Use that chat feature. See if you can't type it in. You can use like a caret, the caret key to show powers. All right, excellent. So we are going to start with the highest power of a negative 2y cubed. That would be the first term we would write. We would move to our next highest power, plus 4y squared. Continuing on then to 5y, and that would be plus 5y. And then our last term would be in negative 3. This is descending order. Again, starting with that highest power of cubed, moving down to the lowest, which is just our constant of a negative 3. So another word we need to know is coefficient. And coefficient is the number that's in front of a variable. For example, the coefficient of 8x squared is 8. Sometimes if we had just something like x cubed, the coefficient there would be 1, even though we don't normally write that. So that's just a little vocabulary to make sure that we're all on the same page as we talk through this lecture today. A little bit more vocabulary. Monomial. We can think mono, meaning one, has one term. And notice that one term can have a couple of variables with it. Okay, hold on, I see French's question. I'll get to you that in a second. A monomial has one term, but it could have a couple of variables in there. A binomial has 2 terms. And then the trinomial has 3 terms. And French, your question, if 2 variables are to the same power, then alphabetically, yes. So, for example, if we had something like x squared and a positive 7y and a negative 4y squared, we would write this then with our highest power alphabetically first. So we would start with x squared. Then we would move on to a negative 4y squared. and then we would finish off with 7y. Okay, absolutely. So if for some reason there are more than one variable, and we're trying to add or subtract or put those terms into descending order, we would go alphabetically, looking at x squared as being before the y squared. Good question. Okay. Otherwise, again, monomial, binomial, trinomial are other types of polynomials. They are polynomials that we're going to be looking at and working with. And so what we're going to be doing with these when we add and subtract is we're actually going to be looking to combine like terms. And we've been combining like terms at kind of a basic level in other things, such as 2x plus 3x. We've looked at those kind of ideas and said 2x plus 3x we know to be 5x. But looking into other like terms, we have something like m to the fourth. Here we have 8m to the fourth, and we're subtracting 3m to the fourth. That means we have a total of 5m to the fourths that are left. We could look at something like y cubed z to the fourths. If I start with 7 of them, and I add 15 of them, then I have a total of 22, y cubed z to the fourth. Notice that we don't do anything, like we don't add these y cubed z to the fourth, okay? We don't all of a sudden get 22 y to the sixth z to the eighth. We're looking at these as a term, and the variables in the term have to be exactly the same in order for us to add or subtract the coefficients. So again, looking at this, 8x squared and negative 13x squared, those are like terms that can be combined. But 8x squared and a negative 13x are not like terms. X squared and x's cannot be combined together. Similarly, we could have these y cubed z to the fourth, which we could combine together, but we cannot combine y squared z to the fourth with a y cubed z to the fourth. Those are different terms. Okay, those are different. So to look at this, we'll actually match like terms. And there are 4 of you. So I'm going to assign you each a matching. So hopefully you're hanging with me here. Deborah, I'm going to have you figure out 1, what does that match to, and combine that together. French, I'll give you number 2. I want you to figure out what matches with that. Peter, let me give you number 3. What matches with number 3, like term, and combine those together. And Ronmel, I'm going to give you number 4. So go ahead, figure out what matches, and type in like 1-A if those match together, and figure out what they combine to. All right. Using that chat feature, go ahead and type in what matches together. All right, so we're getting some of you matching these up together. Excellent. And then you can go ahead and figure out what do they equal. Good. So Deborah says 1 and C match together. I agree. And then Deborah, what do those add up to when we combine them? Okay, so close. We have 6 x squared y cubes, and we'd be adding to that 3 x squared y cubes. So I guess we're adding in this instance. So okay, we're adding in this instance, so 9. Yep, 9 x squared y cubes. And then French, I saw that you posted. You said 2 and D go together. Absolutely. And what do those combine to? When we combine those, good. Negative 7 x squared y squared. And Peter, combined his, 3 and A, and 3 and A, when you combine those together, good, you get a negative xy cubed. And Ron Mel combined his together, 4 and B, and got 10x cubed y squared. All right, thank you for your participation on that. So that's combining like terms. And again, what you all recognize is the idea that the variables themselves do not change. What's changing are those coefficients when we add and subtract like terms. Another thing to keep in mind, and this is going to be important when we look at our next slide here, is order of operations. We like to start with our parentheses and always looking to see if anything simplifies within parentheses. Then we move on to our exponents. Multiplication and division are kind of equal in terms of order of operations. You can multiply then divide, or you can divide then multiply. Same with addition and subtraction, they're kind of equal. And what we normally say is we go left to right in terms of order of operations once we get down to something, you know, that's equal in nature. So looking at those order of operations, we have something like this. 3a squared plus 5a minus 7a squared plus 2, and we're subtracting from that 4a cubed minus 3a plus 4a cubed plus 5. In order of operations, P parentheses, I'm going to start by simplifying what's in parentheses, and I see that I have a 3a squared and a negative 7a squared. So in my first parentheses, I can simplify that to a negative 4a squared. I have a 5a that doesn't simplify with anything right now, and a positive 2. I'm subtracting from that this whole second expression. And we can see we have a 4a cubed and a 4a cubed, so we are going to combine those to be 8a cubed. I have a minus 3a and a positive 5. So now I have simplified what's in parentheses. Next, I'd look at exponents. Well, I have nothing being raised to an exponent that needs simplifying right now, so I'm okay there. Multiplication and division. You can think of this subtraction sign one of two ways. It is subtraction, but we could also think about it as distributing a negative, which is kind of multiplication. So at that point then, I think I might distribute this negative because it is kind of multiplying to each of those terms. So I'm going to get a negative 4a squared plus 5a plus 2. And then again, I have to look at saying I'm subtracting from that this whole expression. So I'm subtracting from that 8a cubed. I'm subtracting a negative 3a. Subtracting a negative would really be adding. And I'm subtracting from that 5. And now I want to add and subtract my like terms. And remember that I want to be in descending order. So adding and subtracting like terms, descending order means I want to start with my highest power, which is my negative 8a cubed. Then I'm going to go on to my next highest power, which is a negative 4a squared. I'm going to look for any a's, and I see that I have a plus 5a and a plus 3a. So I'm actually going to end up with an 8a. And then my constant at the end, plus 2 minus 5, would be minus 3. So that's adding and subtracting polynomials. But now I'm going to give you kind of a little bit more difficult one. That's going to deal with exponents. So I want you to think about it, work on it. I'm going to set up a poll here. So once you simplify this, my question is, what is the coefficient of the m squared term? And again, for polling, you have your 4 icons right above the chat main room feature. which says, smiley faces, stepping away, raise your hand, or an A, and so you can pull A, B, C, or D. So when you have simplified that, again, thinking of order of operations, parentheses and exponents, multiplication, then division, addition, and then subtraction. Once you've combined it, what might your m squared term? What is the coefficient? And then pull in your response, A, B, C, or D. Okay, I'll give you another 30 seconds. I know you're still kind of working and thinking through some of this. So go ahead, think about it, and then when you're ready, pull in. Okay, looks like everyone has pulled, and we'll see what's going on here then. Most of you have chosen C with a little variation there. I'm going to push that off to the side. And let's go through this. Again, thinking about order of operations. And really we were hitting the idea of the parentheses and exponents in this one. So in our first parentheses, negative 4m squared plus 7m, nothing can be simplified. So that's fine. In our second parentheses, though, we're really concerned about this piece. How do we simplify this? Well, our order of operations says first look within our parentheses, 3m. Well, there's nothing that can be simplified specifically within 3m. So then we look at exponents, and we see that we have a squared there. So we need to square 3m. Squaring 3m, I get 9m squared. Now note, I only squared what was in parentheses. The 2 is actually being multiplied to that. So right now, I've only simplified using the first few order of operations, which is parentheses and then exponents. And now I can see 2 times 9m squared would give me a negative 18m squared. And I'm now going to be subtracting a negative 4m squared plus 7m. I'm subtracting from that 3m minus 18m squared. Okay? And so now combining this, I see that I'm subtracting 3m, subtracting a negative, which means I would be adding 18m squared. And I have a negative 4m squared plus 7m. And now we can see combining our m squares, a negative 4m squared and a positive 18m squared, does indeed give me 14m squared. And just to finish this off, 7m minus 3m would give me plus 4m. So those of you who chose 14, excellent work. It is 14 would be the coefficient in front of the m squared term. So that was adding and subtracting polynomials and paying particular attention to the idea of order of operations. We are now going to be looking at the idea of multiplying and dividing polynomials. And I put this graphic from Signs up. Signs is a great movie. Mel Gibson's in it, even though his picture isn't up here, and they had these tin foil hats. Well, I took the tin out and just I'm going with the idea of foil. because FOIL is a term, it's an acronym that we use in mathematics when we look to multiply two binomials. Very popular acronym. So we'll be looking a little bit more at that when we work on multiplying and dividing polynomials. So first we're looking at multiplying a monomial by a monomial. And remember, monomial is one term. And we've actually already done this when we were playing with exponents. Our exponent rules help us when we're multiplying a monomial by a monomial. We know we're going to multiply the coefficients, 6 times 3 to give us 18. Then we have to multiply our x squared and x to the fourth. Remember, x squared times x to the fourth. Go ahead and chat me. What are we going to do with those exponents? What is this going to equal? Because what do we have to do with those exponents, x squared and x to the fourth? Exponent rules tell us, good, that we need to add, and once we add those, we will get x to the sixth. If you've forgotten that idea, the idea is we have x times x times 4 more of them, and we can count up then that we have 6 of them. And then y times y to the 7th, we can make that y to the 1st. Same idea, y to the 1st times y to the 7th, like bases, we add to get y to the 8th. So we've multiplied a monomial by a monomial before. That's not new for us. A polynomial by a monomial. So we're looking at a little bit longer term here, 4x squared plus 2x minus 7, and we're multiplying that by the monomial 3x. And what we need to do, similar to when we have that subtraction sign idea, we're going to be distributing 3x. And in other modules, we've kind of looked at that, but now more formally, we can see this distribution occurring. So in distributing, we have 3 times 4 gives us 12. X times x squared gives us x cubed. 3x times 2x would give me 6x squared. And 3x times a negative 7 would be a negative 21x. So a polynomial by a monomial, again, nothing that we haven't maybe seen or talked about or worked with before, but just kind of formalizing that idea right now. What haven't we maybe worked with before is this idea of a binomial by a binomial. And a binomial by a binomial. This is where we look at that idea of FOIL. And in foiling this, you can see I multiply the first term in each of them. So my first term of 2x times my first term of x would give me 2x squared. My outer terms, 2x times a negative 6, leaving me with negative 12x. Inner terms would be 3 times x. And the last terms, 3 times the negative 6 is negative 18. Then we need to combine our like terms, which are these middle two. And this leaves us with the idea of 2x squared minus 9x minus 18. Now, FOIL, again, is just an acronym that helps us understand how to multiply. It's not the only way, though. The idea, though, is we need to distribute and make sure that each term is being multiplied by the other. So here is another kind of fun way. It's called the man with the big nose. We can multiply those first ones. Again, we would get x times x is x squared. We can multiply negative 3 times positive 5 to make the rest of the eyes. Our nose could be our inners, and our outers would be the big smiley face. Again, the idea is we have figured out how to multiply each term together. So with that, there's 3 of them here that I want you to work on. Let's see, Deborah and French. Why don't you two work on the first one? And Peter and Ramnell. Why don't you two will work on the second one? See if you, when you type it in, if we get the same answers, and then we'll talk about the third one together. Okay, so French has multiplied the first one. Deborah, I'm hoping you can either agree or disagree with what she has figured out. And then Peter and Ronmel, I see Ronmel has figured out the second one. And Peter, again, if you could agree or disagree, so that we can take a peek at that. Okay, so Peter agrees with Ronmel, and Deborah agrees with French. So French and Deborah have come up with the idea that 2x plus 7 times x minus 5 leads us to 2x squared minus 3x minus 35. And they found that by saying 2x times x is 2x squared, we would have a negative 10x and a positive 7x. So we can see that that combines to the negative 3x. And 7 times the negative 5 is negative 35. Using a similar method, Ronmel and Peter have figured out that we have 20x squared plus 21x minus 27. And this last one I want to talk about, because when we FOIL or multiply these things, we get x squared minus 3x, fix that, plus 3x, and minus 9. And what I notice about those middle two terms, negative 3x and the positive 3x? Well, we can notice that when they add together, they equal 0x, right? Nothing. So then we are left with x squared minus 9. This is a really important case. It's the sum and the difference of the same two terms. So when we're given x plus 6, and those same terms, x and 6, but now we have a minus sign, we can recognize that in that we have x squared plus 6x minus 6x, or minus 6x plus 6x, and minus 36. And again, those middle two terms, they add to 0x, right? So they're going to drop out every time to give us the square of the first one minus the square of the second term. So that's kind of our rule, is that the product of the sum and difference of the same two terms equals the square of the first term minus the square of the second term. So quickly, I'm sure you can type in then, what would r minus 8 times r plus 8 equal? Excellent. We get our square of our first term, r squared. Our middle terms would add to 0x. And we're subtracting from that the square of our second term, 64. So that's just kind of a special case of binomials that's going to be really important next lecture when we talk about factoring. But for right now, we're going to look at that and recognize that. Something really important, a common mistake that I see, is this idea that x plus 2 quantity cubed, students also think it's x cubed plus 8. They'll distribute that cube to both pieces. But that is not true because we cannot distribute, okay? You cannot distribute over an addition or subtraction sign. So no distributing over addition or subtractions. Only when we're multiplying and dividing can we use that idea. Really what x plus 2 quantity cubed is trying to tell us is it's x plus 2 times x plus 2 times another factor of x plus 2. 3 factors of x plus 2, 3 binomials, are being multiplied together. So we can use FOIL, or again our distribution idea, to multiply the first two terms. This would give us x squared plus 4x plus 4. Then we have this trinomial x squared plus 4x plus 4, still multiplied by the binomial of x plus 2. And a lot of people like to use all the distribution to do x cubed plus 2x squared. They'd continue on to do 4x times x, 4x times 2. This would give us plus 4x squared plus 8x, and then plus 4x plus 8. And we could combine like terms from there. Miss a squared? I think I missed a squared there. To me, this sometimes gets a little fuzzy in my head, as you can even see. I missed a squared when I wrote it all out. So I like to use something like called the array model. So let's take a look at what that is. The array model is really just a table to help us multiply. So if we have two polynomials that we want to multiply together, again, you could take and go 4x squared times 5x squared, 4x squared times a positive 4x, 4x squared times a negative 3. You know, I kind of draw all those lines to remember the distribution. Or what I do is I put this into a table. Notice how I have 4x squared minus 3x plus 7, one of our polynomials along the top. Then along the side, I have our second polynomial, 5x squared plus 4x minus 3. First, in multiplying these, I'm going to multiply as if almost this was like a times table. So I would take 4x squared times 5x squared to get 20x to the fourth. Take 5x squared times a negative 3x, giving me a negative 15x cubed. 5x squared times 7 gives me a 35x squared. And I'd continue filling in this table because this is completing all of the multiplication that I need, just sort of in a little bit more organized format. And finishing this off then, I get a negative 12x squared, positive 9x, and a negative 21. If I were to have completed with my distribution up here, I would have had all 9 of these terms. Now, what are we going to do with these terms? Well, we need to add them up. And in adding them, what's very slick about this is if we look along the diagonal, we can find our like terms. So again, writing our answer then in descending order, I have 20x to the fourth, 16x cubed minus 15x cubed would be a positive 1x cubed. 35x squared minus 12x squared minus another 12x squared. 35 minus 12 would be 35 minus 24, which would be 11x squared. 28x and 9x added together gives me 37 x's. And I'm left with negative 21 at the end. So this array model is just one way to keep your multiplication organized when multiplying polynomials together. Okay, we'll skip that. We'll go on to division. Dividing a monomial by a monomial is something that you've seen, we've done in terms of exponent rules. We would divide 21 over 7. And you can see I've written this out in kind of a lengthy way, and we get 3. And then x to the fifth over x squared, we get x to the x third left because 2 of them have divided away and we're left with 3 left. So monomial by a monomial you've probably seen and worked with already with exponents. But something interesting is a polynomial divided by a monomial. We need to split these apart into fractions. Let me give you an example why. We could do something like this. 3 plus 5 all divided by 3. all right? Oftentimes, you know, we can look and recognize that this equals 8/3. Now, this is a very simplified version, but oftentimes what I see in more complex versions is students will divide the first few away. And if we see we divide those first few, 3 and 3, well, that equals 5. And this expression definitely does not equal 5. What we would have needed to do is break that apart into 3/3 plus 5/3. We're going to use that same idea of splitting apart a fraction when we work with polynomials being divided by a monomial. So here our polynomial is 9x squared plus 6x. We're dividing that whole thing by 3x. Again, we cannot just divide 9 over 3 or x squared over x. We need to look at these as split apart into our two different fractions. And when we do that, then we can see 9 divided by 3 is just 3. X squared divided by x is x. And 6x divided by 3x is 2. So this simplifies our polynomial being divided by a monomial. Why don't you try this next one? Split it apart into two fractions and see if you can't figure out what this would look like in a more simplified version. All right, both Mel and French have checked in, and what they're seeing is that when we split this apart, 30x cubed y to the 8th divided by 10x y to the 6th. Simplifying this, we have 30 divided by 10 is 3. X cubed over x gives us x squared. Y to the 8th over y to the 6th is y squared. That's our first term. That's being added to 40 x to the 5th, y to the 7th, being divided by 10 x y to the 6th. And simplifying that, 40 divided by 10 is 4. X to the 5th over x gives us x raised to the 4th. And y to the 7th over y to the 6th is just y. So excellent work, excellent work. That's dividing a polynomial by a monomial. That actually concludes all of the polynomial stuff that we're going to look at, adding, subtracting, multiplying, and dividing. So before we finish with function notation, are there any questions about all of this addition, subtraction, multiplication, and division of polynomials? French, long division of polynomials. Not in this course. Again, this course is aligning to college readiness. So we are aligning this, you know, the MOOC team aligned this so that it had what was needed in order to enter into a college credit-bearing class. Long division of polynomials is not something that we work with until our credit-bearing class. So is there long division of polynomials? Absolutely, but in this class we're not working on that. But I encourage you, if you really want to seek out and look at other resources. There's many resources out there that help you with long division of polynomials. Okay, so continuing on then, we're going to be looking at functions. Okay, and for the fun of it, let's first look at how do we use the word function in a sentence. Just go ahead and give me some sort of sentence that we might say that uses the word function. One example I can always come up with is, I do not function well without coffee. What other ways can we use the word function? Just a sentence. You can type it in using the word function, not math related. Okay. How well you do on a test is a function of how much you study. Very good. I don't function at night. Okay, good. So looking at Deborah's, how well you do on a test is a function of how much you study. So the relationship we're looking at here is your performance on a test with the amount of time you study. French here, her relationship is herself, I, with the relationship of night. Mine would be the opposite. French, I function well at night, and I do not function well in the morning. So in general, what is function helping us with? It's helping us establish, some days I'm lucky, it's helping us establish a relationship between two things, okay? And in mathematics, it's no different. What is this relationship that we're going to be looking at? Well, going back to our understanding kind of graphs and linear equations, we're going to be looking at this in terms of the function between x and y. Sometimes the function between an input and an output. So, functions. There's a couple things we're going to look at to make sure that we have an understanding of functions. The big rule for functions is that for every x value, there's only one y value. Okay, when we're graphing these things out, it says for every x value, there's only one y value. Well, what does that mean? Quickly, our poll now is just a yes, no. I want you to look at A here, just A, and say, is A a function, yes or no? Is A a function, meaning for every x value, there's only one y value, only one output of a y value? Okay. 3 of you polled in and said, yeah. Okay. A is a function. And we can see that here because our x value is 1. The only y value it's associated with is 3. Same with 2. 2 is only associated with 4. And an x value of 4 is only associated with 7. Okay. Same question. B. Is B a function? Yes or no? Is B a function? Yes or no? All right, we're all very clear on this one then. B is not a function. And the reason it's not a function is because this x value of 1 does not have a unique relationship with y values. The relationship here is that x goes to both 3 and to 4. So this function relationship then does not hold true for B. We can continue looking at like this, or we can look at it in the idea of a T-chart. So let me switch the poll to A, B, and C. And I want you to figure out which one, A, B, or C, is a function. Okay? Got the poll ready for you now. So which one, A, B, or C, is a function? Yes, it is a function. Okay, everybody has polled in. And okay, so it looks like some people are looking at B and some people are looking at C. So what is the function? Well, we said A is not a function. Okay, no one chose A. We can see that. 7 goes to both 4 and 5. Okay, so no, not a function. So is B or is C a function? Well, B says -2 goes to 5. Does -2 have a relationship with any other y value? It doesn't look like it. 3 has a relationship with 7. And 3 doesn't have any other relationship that we know. 5 goes to 5. Now, it's okay that we have the same y values. Remember, for every x, there can only be one y. Okay? So this is still holding true, and 9 goes to 8. That's, again, completely okay. So I think B is a function. All right, but why is C not a function then? And the answer is here. 1 goes to 6, but 1 also goes to 8. That x value does not have a unique relationship with y. So because of that, then C is not a function. All right, so B. B is our function in this instance. Okay. Well, that's just kind of a basis of what is a function. There's a lot more that goes into depth about functions, but we're just going to spend the remaining time here looking at notation and kind of functions as machines, input-output. So functions have a special notation, f of x. The parentheses is read as an of. So this is read f of x. Okay. Our little poster here from the 1970s, it looks like, tells us that f of x equals y. It really is sort of kind of a fancy way of saying y. If you go back to some sort of y equals idea, as if we were in lines, we can say f of x. There's more to it, but right now we're going to just kind of look at it as a different way to say y. And it's important to know that these things are not being multiplied. F is not being multiplied to x. We're talking about this in terms of a function, f of x. So sometimes we describe functions like machines, where we say there's some sort of input and some sort of output. So let's consider this function, f of x equals 2x minus 1. Again, if you want to, you could think of this as y equals 2x minus 1. And we can remember y equals 2x minus 1 is a line that has a slope of 2 and a y-intercept of -1. But instead of graphing this now, we want to say find the value of f of 4. So that means what's going in to our function machine is 4. The rule of our function is 2x minus 1. Well, if 4 is our x, that means anywhere we see an x, we're going to replace that with 4. So this gives us 2 times 4 minus 1, or 8 minus 1 equals 7. So what we would say is that f of 4 equals 7. Okay, that's just a little bit about functions. Now I want you to try, using this same rule, find the value of f of 5. Okay, I see 9 and 11. 9. Yeah. So the idea here is we're taking f of 5 equals 2 times 5. Oh, no apologies around now. Minus 1. You probably had add 1 in your head, which means that f of 5 equals 10 minus 1, or 9. Well, functions don't always use f of x. In fact, we can name them kind of anything we want. G of x, h of x, m of w. Doesn't really matter. The most common one, though, we consider to be f of x. So again, now I want you to try using a little bit more complicated function. H of x equals 2x squared plus x plus 1. What is h of a -3? And again, the idea here is given this function, I want to find h of a -3. Go ahead, see if you can't figure out what h of a -3 equals. Okay, good. Several of you have said 16, so let's take a peek at that. We would have 2 times a a negative 3 squared plus a negative 3 plus 1. So the idea here is that negative 3 is substituted in anywhere we see an x value. And now solving this, h of a negative 3, negative 3 squared is 9, times 2 is 18, so again we have to worry about our order of operations, minus 3 plus 1, which sure enough then we see that h of a negative 3 equals 16. Okay. Well, that's functions with constants that we're plugging in. But something a little more complicated then, let's say we're given g of x equals 3x minus 5, and we want to figure out what g of w plus 1 is. So we're no longer plugging in just a number, we're actually plugging in a whole expression. So what's going into our function is w plus 1. We're given the rule 3x minus 5. And now we need to find 3 times w plus 1 minus 5. Again, I've seen that I have an x in my rule, but I want to find w plus 1. So g of w plus 1 then would be 3 times w plus 3 times 1 is 3 minus 5. Or our output then would be 3w minus 2. Okay? So, we'll do a challenge problem. So we have just a little bit of time left. So let's say I give you now g of x equals x squared minus 2x. And I would say find, given that function, I want you to find g of y plus 1. Go ahead and see. There's a couple of minutes we have left here if you can't figure that out. Again, you're going to have to be a little cautious thinking about order of operations, some of the polynomial stuff we got with today. And we're going to end on this idea. As you're working through it, thinking about it, I will show that we need to recognize that y plus 1 quantity squared minus 2 times y plus 1 looks like our first expression here. All right, French has given us one idea here, y squared minus 2y minus 1. What I want to make sure that I highlight here is that y plus 1 quantity squared, we need to make sure that we look at that as y plus 1 times y plus 1. This is a binomial that we need to look at. And yeah, that's why this is the challenge one. So if we look at this as a binomial, then we get y squared plus 2y plus 1. So y plus 1 quantity squared equals y squared plus 2y plus 1. We're subtracting from that 2 times y and minus 2. So that means now when we combine our like terms, g of y plus 1, we would get y squared plus 2y minus 2y. Those are actually adding up to 0 y's. Then we have a plus 1 and a minus 2. So we're left with negative 1. So g of y plus 1 equals y squared minus 1. Good, nice work. All right, well that's a lot for today. All the polynomials and function notation. Are there any questions that you have that I can answer for you? If not, thank you so much for your participation. And good luck as you move ahead in the Math MOOC.